Okay, so in our next area of emphasis with regards to our trig function values, we're going to take a look at what is commonly known as the sine. All right, don't confuse this with the sine function of an angle. Right, when I'm talking about sine here with the G, I'm talking about where am I positive, where am I negative. So for what angles, right, is sine positive? Where's cosine positive? Where's tangent positive? Where are they negative? All right, and so that's pretty much what we're going to investigate. I'm going to use the definition to help me explain my answer. I expect the same out of you guys as you guys do things. So, you know, obviously you have your calculators and whatnot to explain some things. I think there's some acronyms out there that might, but I want you guys to be grounded in the definitions. The better you know the definition and you can use it and you can explain things from it, the stronger you will be when we need some things later in our class. So make sure you're paying attention and not just relying on technology or some silly acronym. So how do we figure this out? On one last thing, you notice I'm concentrating on the big three. All right, sine, cosine, and tangent are the big guys. Cosecant is the reciprocal of this one, so whatever this guy does, so will cosecant. Cosine, right, the reciprocal is secant, so whatever cosine does, secant will do. And the same thing for tangent. Cotangent is the reciprocal of tangent in terms of their ratios. So whatever tangent does, so does cotangent. So that's why I'm going to focus on the big three. So how do we do this? So if we look at my first example, I'm trying to find, right, what is the positiveness or negativeness if my theta has a terminal side in quad 2. And so a picture will be appropriate here, right? So we're talking about being on the quad 2. So there would be a potential picture of the situation going on, right? My initial sides along the x-axis, my terminal sides in quad 2. So in terms of an ordered pair over here, right, my x will be some negative value and my y will be some positive value, right? And then the other thing that impacts sine, cosine, and tangent is r. But we know r, by definition, is x squared plus y squared. So when I square x, I'm going to get a positive. When I square y, I'm going to get a positive. So when I take the square root of a positive, I'll get a positive. So we know, without a doubt, that r is always positive. And so we can put this together now with our definition to find out, well, in this quadrant, what do I expect out of my sine, cosine, and tangent values? So by definition, the sine of theta is my y coordinate over my r. And in this particular quadrant, my y is positive and my r is always positive. So when I take a positive and divide it by a positive, what I get is a positive. So the sine of theta in this quadrant will always be greater than 0. And that's just another way of saying that you're positive. What about the cosine of theta? Well, by definition, it's x over r. In this quadrant, the x happens to be negative. The r happens to be positive. So what we get is a negative value. And I take a negative divided by a positive. So in this quadrant, the cosine of theta will always be less than 0. That's just another way of saying that cosine will be negative. Last but not least, tangent of theta in this quadrant. Well, by definition, it's y over x. In this quadrant, y is going to be a positive value and x is going to be a negative value. Positive divided by negative is a negative. So in quad 2, the tangent will be less than 0, right? It'll be negative. And so that's how I use my definition, right, in conjunction with a picture to explain the positives or negativeness, all right, in quad 2. And this occurs for all of them, right? 91 degrees, 179 degrees, 133.7. All those angles have a terminal side in quad 2. So all of them, right, I expect the sine to be positive, the cosine to be negative, and the tangent to be negative in that quadrant. So moving along, right, what about quad 3? Well, again, a picture, right? The situation will look something like this. If I'm in quad 3, there's my theta. My value of x and y, well, in this quadrant, they're both negative, right? And then we already know that r is always positive. So looking at my definition, the sine of any angle in here is y over r. So for this quadrant, the y coordinate is negative, r is always positive. So that means that sine is always negative. It's less than 0. The cosine of theta, right, by definition is x over r. X in this quadrant is negative, r is always positive. So that tells me that the cosine of my theta will be negative again. All right, so cosine is less than 0. Tangent Well, by definition, it's y over x. In this quadrant, y is negative, x is negative. A negative divided by a negative is a positive. So tangent of theta will be greater than 0, or it'll be positive. So you can see there's a switch in sign values for some of these guys, right, as we go from quadrant to quadrant. So quad 3, sine is negative, cosine is negative, and tangent is positive. So the next quadrant is quad 4. Again, looking at a picture, right, we probably have a situation that might look like that. Right, my initial and terminal side, there's my theta. In terms of an ordered pair on the edge here, my x coordinate will be positive and my y coordinate will be negative. And of course, we still know, because of the way we develop r is always positive. And so we're basically back to our definition. So sine by definition is y over r. In this quadrant, y is negative, r is always positive. So for quad 4, sine is going to be negative, less than 0. Cosine, right, by definition is x over r. In this quadrant, the x value is positive, r is always positive, so the cosine of theta will be greater than 0, or positive in that quadrant. And then last but not least, we have our tangent of theta, right? By definition, it's y over x. In this quadrant, the y coordinate is negative, the x coordinate is positive, so negative divided by a positive is a negative, so my tangent will be less than 0. Okay, and then of course quad 1, what's nice about quad 1 is everybody's positive. X is positive, Y is positive, R positive. So all my ratios will be positive over positive. So that's why I didn't address that. So that's the kind of nice thing. So in this, I guess if you kind of look at some things here in terms of sign, what's nice in quad 1, everybody's positive, right? In quad 2, just the sign's positive. In quad 3, just the tangent is positive. And then in quad 4, just the cosine is positive, right? And then, there's some acronyms that are built around that, or some things of that nature. But again, there's the definition showing you why we are what we are, positive or negative. All right, so that wraps up that discussion. Cut to the next video where we talk about subquadrantal angle information. See you guys then.